Well, hello to the awesome students at Cal State Straub. This is our last set of notes for Chapter 13. Woohoo, woohoo! The last chapter that this year's AP test will be covering. So we've got a little bit to do. One of the things I want to do first is a warm-up where you're going to practice a two-sample proportion test like we learned yesterday. When you are done with this question number one, in doing that, I would like for you to answer number two and connect what you did with your CI. Actually, we're doing a confidence interval first. What you got with your confidence interval and what that would mean for a significance test. But notice it says do not perform the test. Just tell me from your CI, what would you say about the significance testing? And since this is going to be a two-tailed test, we are able to make that indication. So work on that and then come back and check your work with me, okay? All right, let's see how you did with question number one at first. Let's just come there, okay? You need to establish the p-hats because it didn't give it to you exactly. So we do our x over n's for each of those. So you can see here that I have the p-hat of the west and the p-hat of the east. And then make sure that you let your readers know what your parameter is and what your population is. So this is the proportion of the Western Conference games that were considered high scoring. And this is the Eastern. Okay. Then conditions for plan. Oh, by the way, up here should say, ooh, Mrs. Straub would lose a point here. I don't have a two sample Z test for proportions. Okay. Conditions, SRS, is given for both. Remember, they have to cover both. When I do my N1 times P hat and times 1 minus P hat, I get numbers that will both be greater than 5, is all they have to be is 5, but they're definitely greater than 10. And again, in my short notes, I didn't say exactly what those equal here, which you should be doing on your papers, whatever those values come to. Okay. Independence, we did it for both. And now we can move on to the do. So here is I just stuck the formula in. And you can do the subtraction of the p-hats. Notice we're noticing the direction of the difference. I have west minus east here. And then when I do west minus east, I get a difference between here and here. So it's telling us that the Western tended to have higher percentages. Yeah. So we're 90% confident that true difference in proportions, west minus east, notice the direction is written there, of high scoring games is between 3% and 33%. Quite a big range there. But we are doing, 90% confident. So we're opening up that interval quite a bit there. Okay. Hopefully you came up with that. Of course, 0 is not in this interval. So that means that we would probably, with our significance test, come up with a conclusion that that would reject the HO, there being no difference, and say that there is a difference between the proportions since 0 is not in this 90%. Of course, that would be at the 10% level, the 0.1 alpha level to connect with our 90% CI. Okay. All right. Before we get into the notes, the slides, you should have your worksheet handy. If you don't, pause me and make sure you print that out. Every day have these sitting there with your notes. So make sure you have a copy of Estimating a Difference in Proportions in front of you, this worksheet. We're going to fill in the front page first to go back over notes from yesterday. So, all right. I just took down some notes about what the shape will be of this sampling distribution for the difference of two sample proportions. Okay. And that's when we get these conditions, when they are met, when they're at least 5 is okay. I know 10, of course, is even better, but we learned that 5 is okay. Then this sampling distribution of the p hat 1 minus p hat 2s will be approximately normal. I've said this before, but on my webinar with AP, they said one of the things that they dock points for is if students say it will be normal. They want to see that approximately normal in there, okay? Because we're not getting an exactly normal curve. We're getting fairly normal, close to normal, and normal enough to use the z-curve, okay, to estimate. The center of p hat 1 minus p hat 2 is the p1 minus the p2. I showed you that on the sketch drawing that was in yesterday's notes. In other words, it's just saying that the estimates that we use will all, that average of all of those goes to the true parameters being subtracted. Okay. The spread here, well, this is your new standard deviation of the spread. Again, this was the formula we looked at yesterday, the formula that's on your formula sheet. Using the p hats in there, that's the denominator of our statistic. So as long as each sample is no more than 10% of its population, then we can use this. Remember, that's what that condition, that 10N condition allows us to use that standard error in our work. Okay? The NP allows us to do normal, and the standard error formula there allows us, when we get to 10N is less than N, capital N, then that allows us to use that formula for standard deviation. Okay, so just remembering the conditions, they must be random. They've got to come from 2 independent random samples from 2 groups in a randomized experiment. Remember, everything's got to be random here. Our independence, we're doing that 10% check. That allows us to use that standard error. And then our normal condition, again, you use the p hat 1 and 2 when you are doing intervals, confidence intervals. You will use the p hat c when you're doing significance testing. I'll come back to that in case you're still writing it, but notice what we're doing here at the top is we're estimating the difference. So when you're estimating the difference, that means we're doing confidence intervals, okay? When we are doing significance testing, then that would be where we would swap out these p hats for p hat c's. Okay? All right. As soon as you have all of that written down on that note sheet, then we're going to transition. So if you're not quite done, pause and finish writing it, and then join us back. Okay, just a couple of slides today in our notes, which you will be happy for. And that's just to show you how to do all these crazy calculations in the calculator. Okay, if we were going to do a 2 proportion test, significance test, you'd do the same thing, stat test, where we've been going, and now you're going to go to the 2 prop z-test. That means it's a 2 sampled z-test for proportions, and it's 2 prop z-test. I highly recommend this because of the crazy calculations. But you enter your x1 and n1, x2 and n2 from the problem, and then you let the calculator know if it's 1-tailed or 2-tailed, in which direction, and hit calculate. Oh my gosh, so much easier, yay! When you're done, you will get that z statistic and your p-value. It will also give you the p hat c that you need, because you're going to need that to find your SE. You've got to use that denominator formula using the p hat c and the SE in order to get your standard deviation on the sketch that you're going to create. Okay. But if you're doing a CI instead, calculator again, stat tests, and now this will be a 2 proportion z interval, so 2 prop z int. And again, you enter your x1 n1s and x2 n2s. You need to tell it what confidence level, 99, 95, 90. And then hit calculate, and you will get your interval. Boom. That's it. So those two calculator commands really take a lot of the time out of doing some of your practice homework questions and everything like that. Again, you'll still need to know the formulas for your sketches, and that formula is on the formula sheet. Just a reminder, what was P hat C again? What am I talking about down here with P hat C? Remember, that's where you would have taken x1 plus x2 on the numerator and n1 plus n2 on the denominator. All right, so let's go back to your worksheet. And actually, I'm going to go to a blank copy of it and go to the back question. Okay, so here's what I want you to work on. And then I'm going to put some questions in Edpuzzle for you to answer, and we'll go over my key and be done. So it says here, are teens or adults more likely to go online daily? And so you have some information there that tells you information about teens, about adults, their percentages. Aha. So when I look at this problem, I see two distinct samples, and I see that it's on percentages, which is the same as a proportion. So I'm not doing means here. I'm doing two sample proportion z-test. Okay. And so it asks you here, because this particular sheet, we're doing a confidence interval. So it asks you to construct and interpret. That always tells you to put it in context. We are, okay, and then put the context in it. 95%, no, it's 90%, sorry, 90% confident that, say, so would you construct and interpret a 90% CI if you use your calculator? Then be sure to put the box like I've talked to you about with an input box and an output box. What are you putting in and what did it spit out? Just like it would be a screenshot of each of those, okay? And then we'll check the answers. All right, let's begin to take a look at this. Notice I put here we did a two sample Z interval for P1 minus P2. I did put my data off on the side. I've talked to you guys before about that. I like to kind of do some calculations here. So I got my P hat 1 and my P hat 2 calculated off on the side. But here for my state, these are my parameters. The proportion is the parameter this time. And the population is teens and adults for the different ones. And we're trying to estimate the difference at a 90% CI, confidence level. So I'm stating what the problem is. Remember, with confidence intervals, you need to state what it is you're doing. Okay, we go to our plan. Conditions for that. Because it's a confidence interval, I'm using p hats. So there's where I did n p hat 1, n p hat 2, and so on. And all of them are greater than 5. And they're greater than 10 for that matter. So we can assume normal, approximately normal. Independence there, we would pretty much be able to satisfy. And just remember, your last condition is that they are independent from each other. That's super important in all of these two sample tests that we state that in our independence. Okay. Our Z star for 90% is 1.645. And so I did this by hand and in the calculator to show both ways. You only had to do it one way, but there it is, the formula filled in with all of the pieces we were using. Notice I needed to state that it was teens minus adults. We need to state the difference of what's going on here. So teens minus adults. And I get this confidence interval. If you go to the calculator and run that through, here's where what I'm talking about, like that's your input model, okay? And then you would get your output. And you might have gotten a tighter interval than I have here. I don't seem to have that answer put on my paper for some reason. But if you got it smaller, like what I'm saying, tighter, that this is smaller distance between the two, like it's inside these, then that's what happens when we use the calculator. Our conclusion, we are 90% confident that this interval captures the true difference in the proportions of teens and adults who go online every day. What does this mean in context? This means that it suggests to us that more adults go online every day than teens, by between 1.8 and 8.2 percentage points, which is very interesting. But a lot of adults have to work all day on the computers. And so my theory when I saw this data was it could have a lot to do with the work. Although if it was summertime, maybe we'd see more teens on. I don't know. But there you go. There was a practice. What we're going to do tomorrow is notes is we're going to practice a significance test. Or maybe we already did that. Never mind. We're done, huh? So this was just practicing a confidence interval and making sure we have everything down that we learned. Good job. And we're done with chapter 13.